Look at those silly fractions. Okay, so how do you split up these dudes? Okay, we have to find the exact values of sine, cosine, and tangent. So we're going to split this angle up so that we can use the sum and difference formulas. Nasty. How do you do that? Okay, I know we have to take this slow, but you only have to write this once on your paper, then you can do it. Now, give me the angles that you know.
165.
Yeah, you guys know pi over 6, right?
Yeah.
And you guys know pi over 4, right? And you guys know pi over 3. And you guys know pi over 2. Like, you know those ones, right?
Yeah.
If you were to use those. Now, these are written with a denominator of 12. So let's change these to have the same denominator. So this would be 12 on the bottom. I'd have to multiply the top and bottom by 2. So I'm going to get 2 pi on top. This next one, I would get 12 on the bottom. I have to multiply the bottom by 3, top by 3. So you get 3 pi up top. Next one, 12. I'd multiply the bottom by 4, top by 4. I get 4 pi. And then the last one is going to be 12, and the top will be 6 pi because you have to multiply the top and bottom by 6. Okay. Can you guys see how I can use these to get negative 13? Okay, if I make them all negative. Let's see. Because I know like 2 6 pi's would give me 12 pi, but that's I need 13 pi. What if I went 6 pi plus 2 pi plus 3 pi?
Why did you do 6 for?
Oh man, this is mean. No. Okay, 2 plus 3 is 5 plus 6 is 11. Oh wait, I need 4. 13.
4, yeah.
Oh, what if I do 3, 4, and 6?
Yeah.
Yeah.
Okay, is that what you guys said?
Yeah.
Oh, that's what I said. Okay, well, that's kind of boo. I kind of wish that there was a better way to do that.
Yeah, why? That's when there's 3 of them.
Okay, so if there's 3 of them, you can start crying because your life sucks. You guys ready? I'm just going to split it up once and show you guys, and then we're going to be done. Okay, so we got 3. Oh, wait. Hold on. I got to stop for a second. Don't we know pi? Right? We know pi, right? So wouldn't this be 12 pi over 12?
Yeah.
So can I use that? Oh, no, I can't.
No, because you don't have a 1 over 12.
I don't have a 1 over 12.
I thought
Oh,
about
dang it, my life still sucks. Okay. So we have 3 pi over 12 plus 4 pi over 12 plus 6 pi over 12. Oh, yeah, these are all going to have to be negative. Okay. So this is what I would do. I actually probably would keep one of these as like negative 7 pi over 12. And I wouldn't split that one up yet. And I would do all my work with these two right here. Okay? Now the problem is you're not going to know this one. You're going to have to do even more sum angle formulas to find it. I know, man, this looks like beast mode, like Crimea River situation here. Okay, so this is what you got. Okay, we know this. We know what this is. So I'm not going to write that anymore. I'm just going to write negative pi over 2. So it's going to look like this. We have sine of negative 7 pi over 12 times cosine of pi over 2, right? Or negative, because that is negative. Okay, and then because I just made these negative, I'm going to keep my plus sign, so that means I'm going to go plus here. Sine of negative pi over 2 times cosine. Oh man, this is hideous. Cosine of negative 7 pi over 12. Okay, things are about to get pretty. You guys know why? You guys don't believe me? What is cosine of negative pi over 2? No, slowly think about that. Right here, it's 0, negative 1. What is cosine? 0. So 0 times this is 0. So this cancels out. Over here, what is sine of negative pi over 2? Negative 1. Okay, so things aren't that bad. So I have negative 1 times cosine of negative 7 pi over 12. You know what I'm going to do with that? I have to split up that negative 7 over 12.
Yeah, I was wondering. Yeah.
All right, so this would be, now we're on the last part. Oh, man. Cry me river. Okay. We have cosine of negative, 3 pi over 12? Plus negative 4 pi over 12. So you guys see the other formula that we're going to have to do? Okay, we're going to have to do another formula for this one, and then when we're all done, multiply by negative. Yeah, that was a gnarly problem. I'm going to stop right there and let you guys have fun with it.